Hey class, today we're going to continue on with section 3. This is part 3, which is our final part in our measurement chapter. Today we're going to talk about accuracy and precision, and then we're also going to talk about temperature and temperature conversions. Again, if you get confused at any point, please make sure that you ask questions or come in for help. So let's go ahead and get started. Our key question that we're going to answer in the first part of this lesson is, how does the precision of measurements affect precision of calculations that you do? First, we have to understand, what does precision mean? So let's go ahead and define it. Precision is defined as how exact a measurement is. What that means is, does the measurement go to the tenths place, the hundreds place, the thousands place? If you're talking about time, does it give it to you to the nearest minute, to the nearest second, to the nearest millisecond? Even when you're looking about distance, are you giving me an answer to the nearest foot, to the nearest inch, to the nearest centimeter, to the nearest millimeter? How close or how precise is that measurement? And with that, we're also going to talk about and define something called significant figures. Significant figures are all digits that you know when you take a measurement, plus the last one that is estimated. These are all the important numbers that are part of a measurement. This is not in your notes, but this is a good example of the difference between something that would not be considered precise and something that would be considered precise. It says the more precise time can be read from a digital clock. So over here on the right hand side, this is a digital clock. And then it says over here, then can be read from an analog clock. So your analog clock is the one on the left. Now it says the digital clock is precise to the nearest second, while the analog clock is precise to the nearest minute. And all that means is, if you are reading the clock on the left, the little hand points to the 3, so that shows me my hour mark, so I'm at 3 hours. And then my long hand points to my time, so at 12, it is exactly 3 o'clock. Again, this shows me my hour, and this shows me my minute, and there is no other hand on this clock to show me my nearest second. This digital clock, on the other hand, shows me my nearest hour, it shows me my minute, and it shows me down to the second. Because this shows me down to the second, this is a closer or smaller measurement, and it means it's more precise. Another example is if you look at rulers. These are all 3 rulers that measure exactly 1 meter. If I asked you to measure the width of this door, you would hold up the first meter stick and you would be like, well, it's over halfway, so it's over half of a meter, so that's bigger than 0.5. It's a little over 3/4, so it's bigger than 0.75, so you might guess that the width of this door is 0.8 meters. Notice this is to the tenths place, this number right here. If you're using the second meter stick, notice now that we have tick marks to kind of help us get a better or closer measurement. Here we know it's between the 7 and the 8. It's definitely bigger than 0.75, but it's not quite 8. So here we might guess that it is 0.77. This, notice, is to the hundredths place. Then on the last ruler, it gives us even more tick marks. So we know for a fact that it is over 0.77, but it's between 0.77 between tick marks. So we might guess it's 0.772. This is to the thousandths place. We should know that thousandths place gives us a better reading than the tenths place. So this one is considered the least precise, and this ruler is the most precise. Now, that brings us back to the question we asked at the beginning of the lesson. How does the precision of a measurement affect a calculation? So here it says the precision of something that you calculate, your answer, is going to be limited by your least precise measurement. It means you can't get any better than your lowest or least measurement. Now that might sound confusing, so let's use an example. Here it says, if the least precise measurement in a calculation has 3 significant figures, then your calculated answer can only have 3. It cannot have more than that. If we took 2 measurements, mass and volume, mass is a measurement. We can put something on the scale and it can tell us how many grams something weighs. Notice here that significant figures are all your known digits in your measurement. So this one has 1, 2, 3, 4 digits. And notice it goes to the hundreds place. Volume. If you were to measure volume or how much space something takes up, and you look at this measurement, you're going to note that it has 1, 2, 3 significant figures, or 3 parts that are part of that measurement. Notice your least number, or your least precise, is 3 digits. That means your answer, when you calculate this, and we talked about yesterday, mass divided by volume gives us our density. You're originally going to get this super long number, but your answer can only be based on 3 since it was your least precise. You can keep the 7, you can keep the 8, and you're going to notice that there's a 5 here, but they wrote 6, and that's because the 7 behind, since it's bigger than 5, rounds up that 5 to a 6. Now, we use this word precise, and sometimes you might hear somebody say the word accurate. And I just want to illustrate that precision and accuracy are not the same thing. Again, precision is how well is the tool that you are using to measure. Does it go to the hundreds, thousands place, minutes, second hands? Accuracy is how close that value is to the actual value of being measured. For example, we said that the digital clock was very precise because it measures down to the second hand. But if your digital clock is actually 15 minutes slow, that means the clock, while it is still precise, is not accurate because it's not reflecting what time it actually is. So accuracy and precision are one of those definitions that I would know the difference of. If there are any questions on that very beginning part, please make sure that you ask questions, because now we're going to go into talking about measuring something known as temperature. Temperature is measured using a thermometer, which is just an instrument to tell you how hot something is. Now, there are different types of thermometers. There are traditional thermometers we use in lab. There are ones that you have for digital thermometers. You've seen ones that you use to take the temperature underneath your armpit, or you might have one that you swipe across your head to tell you if you have a fever or not. So there are different types of thermometers, but the one that you typically see in science class tends to look like this. Usually there is a tube and it's made up of glass, and there is a red fluid in it. This red fluid, whenever it heats up, expands and actually moves up the tube, and whenever it cools down, will move down the tube. And typically there are markings on a thermometer to tell us. So here, for Fahrenheit, this is between 20 and 40, so this is about 30 degrees Fahrenheit. Again, if this goes up, it tells us a higher temperature. So this picture just shows that when the liquid will rise, if it gets heated up, and then it'll go down when it cools off. Now, there are 2 temperature scales that you are probably most familiar with, and those 2 temperature scales is first Fahrenheit, and the second one is Celsius. Fahrenheit should be super familiar because that's what we use to tell our temperature. We usually say, oh, you have a 99 degree Fahrenheit fever, or today's high is 83 degrees Fahrenheit. Celsius, on the other hand, may not be as familiar, but this is what other countries use in order to tell the temperature outside. One thing to note is that the degree Celsius is actually almost twice as large as the degree for Fahrenheit. So when we get to the end, when we kind of talk about the difference between the Celsius and the Fahrenheit scale, you're going to see that there is a big jump. But we're going to learn how to convert between one scale to the other, and we're going to use the following formulas. These are 2 things that I say star in your notes because you're going to be using them on your homework. To take a little bit of time, I want to illustrate the difference between these two. Notice that we have parentheses, and this comes into account your orders of operation. You guys were probably taught PEMDAS. P for parentheses, E for exponent, then you have multiplication, division, and then you have adding and subtraction. You have to follow your orders of operations when you are using these equations. For example, on this equation, one thing to note is that between this 5/9 and this parentheses, you are multiplying. The other thing I want to point out is you have parentheses around the Fahrenheit and the 32. So this part of the equation, you have to do first. Once you find this answer, then you can multiply it by the 5/9 second. The equation over here on the right-hand side is a little bit different. Notice that your 32 is not in parentheses this time. So because it is not in parentheses, you are actually going to take your 9 divided by 5 times your degrees Celsius first as your first step. And then you are going to add 32 as your second step. So notice the steps that you take are going to change. Now, Celsius and Fahrenheit are not your only temperatures. Yesterday, we went through the 7 base units, and our base unit for temperature, we said, was Kelvin, which is illustrated by a capital K. Kelvin can be measured usually in positive numbers, and the lowest you can possibly go is 0 Kelvin. Again, 0 Kelvin refers to the lowest possible temperature that can be reached. Now, based on what previous people in integrated science have told me, you have probably learned the term absolute zero. 0 Kelvin and absolute zero mean the exact same thing. Now, in degrees Celsius, absolute zero is actually negative 273 degrees. Again, 0 Kelvin and negative 273 means the exact same thing. And the way they got between those two units is using the equation. Kelvin is equal to whatever your degree Celsius is plus 273. Now, I'm going to go ahead and star that, and I'm going to have you guys write down another equation, which is degrees Celsius equals Kelvin minus 273. It's just a way to undo that equation. Here, this is a little thing to show you the difference between Celsius and Fahrenheit. This shows you when water freezes, our average room temperature, the average human body temperature, and when water boils. Notice that water freezes about 32 degrees Fahrenheit, and that is the same thing as 0 degrees Celsius, and the same thing as 273 Kelvin. All of these numbers mean the same thing, but because they have a different unit attached to it, it looks different. So these units are important. Again, water boils at 212 Fahrenheit, but at 100 degrees Celsius. We are going to work through some problems, and I have these calculators in my classroom, and oftentimes people, when they first use them, are not sure what the different buttons mean. So we're going to go over what these different buttons mean in case you're unsure. First, if you're ever given a classroom calculator, the first thing you should do is you need to hold both the off and clear button down at the same time, and this will clear the calculator's memory. So if someone put a setting on it that is affecting your calculation, or your calculator just doesn't seem to be working right, hold these two buttons down at the same time, and this will clear your memory. The second thing I really want to point out is you have this INT, you will never use this division button. Your division button is right below it. Notice this is going to be your subtraction button. And you might be like, I get that, Mrs. Grove. But people often try to use this button to put in a negative number. In fact, this button down here allows you to hit a negative number. So if you are trying to plug in something like -10, you would hit this negative button and then the 10. A couple other buttons that are kind of important is right here. These are your parentheses buttons. And then last but not least is this button right here allows you to go from a fraction to a decimal. So if your calculator gives you an answer in a fraction like 23.3 over 9, you can change that to a decimal. And those are important because these buttons you might use when you're using these examples. So here are 4 examples that I went over in my class, and I'm going to go through how to solve these, and you're going to be solving some of these on your homework. So the first one is we were given 2 equations for Celsius to Fahrenheit. And you might ask yourself, which equation do I use? Again, just to illustrate, our 2 equations are here. One thing to note is that Celsius, this equation is used if you are trying to find Celsius, because notice it is by itself on one side of the equal bar. If you are going to use this equation to solve for Fahrenheit, because it is on its own side of the equal bar. So if we were looking at our first example, we are trying to find Fahrenheit. So we want Fahrenheit by itself. If you look at the equation, our equation actually says degree Fahrenheit is 9/5 multiplied by degree Celsius plus 32. This is our equation. We then have to plug in, what do we know? We still don't know my degree Fahrenheit, so we're going to leave that the same. We have our 9 divided by 5. Remember, this 9 divided by 5 to this degree Celsius, we are multiplying. Then we have to ask ourselves, what do we plug in for C? And it gives it to us. It tells us it's 56. So we're going to plug in 56. And then we have our plus 32. According to PEMDAS, or our orders of operation, we need to do our multiplication and division first because we have our parentheses right there. So this is the part that we are going to solve for first. If you see a 9 and a line 5, that just means 9 divided by 5, and then you are multiplying that by 56, and here you should get 100.8. Then we got to bring down our 32. We got to add our 32. When you add your 32, you get 132.8 as your answer. But what if you were trying to go the opposite way? What if you start with Fahrenheit and you are trying to get to Celsius? This is going to use the other equation. Because you're trying to get to Celsius, you want your degree C by itself on one side of the equal sign. Your equation that was given earlier in the lesson was degree Celsius equals 5 ninths, parentheses, degree Fahrenheit, minus 32. So here, we don't know our degree Celsius. Our 5 ninths has to stay. Notice between here, we're going to be multiplying, and then we have a parenthesis. This F, notice we're going to plug in, we know F is being 56, so we're going to plug in 56. Then we have a subtraction bar, and notice it says 32, so we're going to copy that down, and then we got to close that parentheses. This one is solved a little bit differently because we have these parentheses right here, and we have something that we need to do. This is going to be done first. So you have to ask yourself, what is 56 minus 32? And you should get 24. Then we got to drop down this part, times 5 divided by 9. So we're going to plug this part in our calculator now. 5 divided by 9 times 24. You're going to get a repeating decimal. So you get 13.3333, it's okay to write 13.3, and you can put the little bar above it, and that just means it's repeating. If you had trouble with some of these or not sure exactly why I did what I did, please make sure that you're coming to ask. For the bottom two questions, notice that I'm going between Celsius and Kelvin now. Celsius and Kelvin. Here, if you are trying to find Kelvin, it should go by itself on one side of the equation bar. If you look at this, we should note that degrees Celsius plus 273 is my equation. Then we can plug in what we know. We still don't know my Kelvin, but we do know my degrees Celsius is 23. We got to drop that plus sign, and then we still have that 273. This one's easy, we just add them. So 23 plus 273 is 296. For our last one, we are trying to find degrees Celsius. So again, we have to keep that on its own side of the equal bar. The equation that has degrees Celsius on its own side, if we look back at our notes, is Kelvin minus 273. So we're going to plug in what we know. We still don't know my Celsius, but we do know my Kelvin. My Kelvin is 260. Minus, and we're going to drop down my 273. 273. Make sure you're plugging this in your calculator the way that it looks. So 260 minus 273. And you should get negative 13. Yes, you want to put that negative sign in order to make it correct. And that's the end of today's lesson. If you have any questions whatsoever, please make sure that you're asking. And otherwise I hope you guys have a great day.